I'll wait 1 more minute and we'll get started, but I'll start sharing my slides here.
Honestly, we can probably wait just a little bit more.
Is it academic dishonesty if I'm planning on taking graphics in the future?
No, it's not. It's definitely not the same. So, especially since it's in Unity. I don't know why I'm showing this. Enjoy my defaultly themed slides. And then nothing special going on in the theme slides. So sorry about that. Can you all see the slides? They should be shared, maybe.
They're not being shared right now.
Oh, am I not sharing my screen? Oh, host has disabled participant sharing.
Yeah, 1 second. Okay, go for it.
All right. Let me go ahead and share my screen. Okay. So just a heads up for everybody. I'm mostly going to introduce some concepts, and then we're going to focus in on mostly Perlin noise. But a lot of the slides here are going to be introducing concepts. So I think what's really important about procedural generation is like understanding the tools you have available. And you don't necessarily have to understand how those tools work because you can Google them whenever you need them. But it's nice to know what's out there for things you want to do. So I just want to give you, the slides are mostly an overview of a couple of, I think, pretty important things whenever you want to do some infinite world generation or procedural world generation. So a good part of the slides will be explaining some, or just introducing those concepts and giving a couple of examples of what you can do that. And then we'll go into making like a Minecraft-alike, basically, where we're going to try to generate an infinite world of cubes with some funny looking terrain. So that looks okay-ish. And then if we get time, we'll talk about biomes and play some trees. All right, I'm ready whenever you are, Alex. So just let me know whenever you want us to get started, or want me to get started.
I think now's a good time. And we are going to be working in Unity today, so we should probably start off with telling people to make the project.
Make a URP project, please. It might not matter, but I did make some materials, but I don't know if they're actually being imported properly. It's not super important to use those materials. I'll demo those materials if I have time, because I guess one of them is an implementation of one of the things I'm going to show you, but we're not actually going to do it as part of the workshop.
So you have Unity installed. I'm gonna share this.
Okay, I'll let you just show that real quick.
So we're gonna be working in Unity. For the version, I don't think it matters too much. Yeah. But just for this one, make sure that you're making it from this template. So you have this selected and then you make the new project.
I would use the newest version of Unity, not the recommended one, but the newest one, I think, because I think there actually might be a distinction between the two most recent, or the recommended one and the most recent version with how shaders work. So.
Okay.
A little bit considering. Okay. Let me go ahead and share my screen and we'll get started. So procedural generation. Ooh, so what is procedural generation? It's not necessarily random, but in most use cases, it's what we want to say is like randomly generating terrain, objects, things for our games. And we want to do this generally because for instance, like something like Minecraft, right? there's no way that we can pre-generate an infinite world. That would take infinite amount of space. So we want to have a mathematical way to generate it. It allows for us to save a lot uh, on file sizes and stuff like that if we generate things procedurally, because then we can do a bunch of variants based off of a certain number of things. So there's a lot of benefits to using procedural generation in your project. But yeah, the foundation, the number one foundational piece is random. So a very basic idea of something you could do that's like very simple procedural generation, where you just use random, would be like maybe people, or like people in a town or something. You could have a bunch of different hairs, a bunch of different body types, a bunch of different faces, and you make sure that they mesh well together. And then you could randomly select them with like just a random dot value, and then you can use like a step function basically to determine which one you choose. So, I mean, I've done this before many times for like, there was, for instance, a game jam where we made a hamster game, and the hamsters were randomly generated. Their like colors were randomly chosen and so forth like that. So this is a very simple use case, but random is kind of our building block foundationally of what we're going to be talking about today for most of these things. Also, feel free to stop me at any times, and I really would prefer if you guys speak up if you want any clarification, especially once we get to the workshop. If you have any questions, I it would be great if you stop me, because a lot of other people might also have the same questions and so on and so forth. So please slow me down if you feel like I'm going too fast and so on and so forth. So the next thing here is just a noise texture, and it is just an implementation of random, right? So it's a texture that is just random value per pixel, right? And value meaning a value between 0 and 1, right? Or 0 is black and 1 is white. So we just, for every pixel, we see the value based off of the X and Y dimension here, right? So like, so the position will determine its seed, and then we can randomly choose a value here. And then we put that into our random function, and it gives us a random value. So it's pure, it's not true random. Nothing is true random in computer science, but it's noise, right? So you've seen this on your TV and so forth and so forth. So noise by itself is not super useful in procedural generation, but we can do stuff with noise textures to be a little bit more useful for things that we might want to do. So this is, for instance, the material I made for you. I used by layering noise textures, which is what the first image is. So what we can do is we can have different, again, I really want you to be familiar with these concepts here, but I might go a little quick here because it's not super, we're not going to be doing it in the workshop, and I just want to introduce these concepts. So one thing we can do with noise is we can layer it, and by layering it, I mean we can have different multiples of noise. So we can say we'll have like a 5x5 grid of noise, for instance, where it's like 5x5 pixels, and then we'll layer on top of that a 10x10 grid of noise, and then we'll layer on top of that a 20x20 or 15x15 and then 20x20. And by layering noise, we can get something more akin to this on the left, where by averaging all that out, we get kind of something a little bit more reasonable and like useful. So this kind of can be imply kind of like a cloud formation or something like that. Or we could even use this as a height map for terrain, which we'll use Perlin, which I'll talk about next, but we will use pretty much noise as a height map for our terrain. And we can also combine these noise values with other functions like circle functions and so on and so forth. And we can get something more interesting like these ring textures for like, if you wanted to do a tree, you can do this with stripes and so on and so forth. So like using random noise with like some sort of mathematical functions can also give you some nice effects like this. And I've linked this article. I'll show these slides. There's a nice article about these textures here specifically and how they made them. So this is probably the most important slide, I guess. It's what we're going to be using today. And we're going to be using Unity's built-in Perlin noise function. So we don't really need to understand how it works, but I'll give you some pros and cons of it, and I'll explain very vaguely on how it works. But Perlin noise is just like pretty much a foundation, like it's one of the most important building blocks for any procedural generation. So like 90%, I would say, of procedural worlds that you'll see are probably using some form of Perlin noise, whether it's like more advanced forms of that or not, like simplex noise. it doesn't really matter too much. But Perlin noise is a smoother form of noise where we segment space and assign a gradient. And these are very mathematical terms. So whenever I say gradient, I just mean a vector to these corners. So that's what this second picture is really how it works. I'll keep going ahead. I need to stop that. Okay, so we assign these random like arrows basically, and then we do the dot product. And if you're not super familiar with linear algebra, just understand it's we're getting basically a single value by multiplying this random direction with the the vector that's its positional offset inside the grid. And again, this is not super important, so if you don't understand, don't worry about it too much. But we do that for all the corners, and that's how we get our random noise value. And basically, it's just a clever hack somebody came up with, and makes, or it's not a hack, but it's a trick somebody came up with to get this nice noise. And
so
it can
how do we? Oh, sorry.
Go ahead.
How do we decide how big of a grid to use?
We're not going to, because Unity's built-in function just says give us a random seed, basically, and like a random float value as a seed. I think it's a float. Oh, actually, no. It takes it. It's Unity's is explicitly two-dimensional, so you give it two values, so an x and y coordinate, and it will do it for you. And again, I need to just point out some of the downsides of this, and we'll actually discover this in our demonstration with Unity's Perlin function. The problem with Perlin noise, something that's not really super well understood, is the dot product between any positional vector and the corner at the corner is going to be flat. So the corners are always going to be the same value, no matter what. So that's something to keep in mind. So Perlin noise has this nice bumpy terrain that's nice and smooth, but all these actually corners are going to be the same value. And we'll run into that issue, or potentially we can run into that issue with our noise function whenever we implement it. But we can just, again, this grid is not really specific, so we can scale it. And of course, Perlin comes in multiple dimensions. It's not just two-dimensional. It can be three-dimensional. So Minecraft actually uses three-dimensional Perlin noise. We're going to use two-dimensional because it's much simpler, and it's built into Unity. So. Another important algorithm, I've implemented this in the package, so if we have time, we'll use it, but I'm not going to bother implementing it. You can look at the implementation. I can explain it after the workshop's done if you're interested. But Poisson, it says Poisson sampling. The proper algorithm is Poisson dissampling. And basically the idea here is we want a somewhat random but even distribution of points where the points aren't too close together. And this is pretty obviously useful for things like trees, and that's what we would use it for in our demo. So we can get an even distribution of points, and that's what this is useful for. So again, I want to just give you an example of what this is useful for. You don't necessarily need to understand how it's implemented. You can look at how I implemented it if you wish to get a better idea on that, and I can explain it too. Another really cool one is cellular automata, and this comes in way too many forms. If you want to see more cellular automata, there's a whole like subreddit based off of it. It's like really cool stuff you can do with this. But generally in games, a very common use case for cellular automata is cave systems. So digging out caves. So if you want to, so I've actually used cellular automata to dig out caves before in my capstone class whenever I took capstone. But cellular automata is just it's actually not really random. It's, you can start with a random state, but what it is it's like, at least rule-based cellular automata, again, it comes in many different forms, is you give a cell a rule of how it's supposed to act, and then you simulate it over a number of, like, a time frame. So you say, like, I want to run this 100 times, and this cell has a certain rule. And you've probably already implemented cellular automata before if you've done Conway's Game of Life in, like, 3.14 or whatever. So Conway's Game of Life is a form of cellular automata. So cellular automata is the overarching name which that falls under. So if you want to learn more about that, you feel free to Google it and stuff. It's really interesting. A lot of cool stuff people do with it. So now with that, I want to leave if y'all have any questions on any of those algorithms. Again, it was very dense, really fast. I just want y'all to have those concepts in your head. But if you have any questions, please ask them now, and then we're gonna get into the actual workshop. Does anybody have any questions?
Okay, so for the package, I think if you're using a version that's not 2020, the shader graph doesn't parse correctly for the grass and stuff. So
it's not super important that it does, but it's just an effect, or it's an implementation of one of those algorithms I said before. So it's if it doesn't show that way, that's okay. We'll just have to add your own materials, but that's fine.
Yeah. And if you don't like swap out the materials, everything's gonna look pink. I mean, like if you don't care about that, sure, you can make a pink Minecraft. That's fine.
So if you all don't know how, just grab this Unity package and just drag it into your Unity, and it'll load it up.
Does anybody need to know where to find that?
This Evan's joining right here.
All right. Well, it looks like most people have it.
Okay, so wait, does everybody have the package loaded in? Like, Diego, did you load in the package and this and stuff? You all have it loaded in? Wait, Tara, did you just join in, or I know Evan just joined in. Okay. So for those of you guys who just joined in, I just went through a slideshow. It's not super important. I just introduced some concepts, but it's not like anything inhibiting. Please download the Unity package. Okay. Cool. And yeah. So once you've imported the Unity package, anybody not, are y'all, so everybody's, I'm gonna wait till everybody's imported the Unity package, but if you have imported the Unity package, go ahead and open up test. Okay, so I think it's got it. So yeah, okay, I think that's everybody then. All right, so open up the test scene, and you'll notice it's a really simple scene. There's the main camera with a movement script, simple camera controller that I actually just grabbed from your URP. So it just comes with the script. And then there's the player script, which is a singleton. If you don't know a singleton, it's fine. But just know it's not anything important. These two scripts, nothing's really special going around. It just means that we can move. And then there's this grid object that has a terrain script, and the terrain script is what we're going to be working with today. That's where we're going to be implementing our noise, our terrain. And if you click play, it should work. And you should see like a cube somewhere. I think, yeah, like just some square. Oops. I don't know why it's being weird. There we go. Yeah, and this grass, I guess grass, if you want to call it grass. I did choose some pretty ugly like radioactive colors, but this material here is using that layered noise approach I talked about earlier. So yeah, if you want to know, that's kind of what it can look like in the real world or whatever. So yeah, so does everybody have that?
I don't think my camera's moving, but that could be because I'm using 2019. Like the character controllers with the WASD, right?
Yeah.
Yeah. All right. Well.
Yeah, it should. If it doesn't work, then see if there's. Do you have any? You created a test scene with URP, right?
Yes.
So there should be an example assets. There might be. Let me see. There should be a script in here somewhere. That is literally. Am I missing something?
No.
Yeah.
That's smart.
There should be another player, a simple camera controller.
Thank you.
I guess not. Okay.
Should I just slap that on the?
Put it on the camera. You can delete mine if there isn't one already here.
Yeah.
If there's one already here, delete it. But I think if I look at sample scene should have a default camera controller, right? Yeah. So there should be
Yeah.
one. You should have one, right?
Still not working. That's okay though. I'll probably figure
Well,
it out.
okay. Check your sample scene, and if it and just basically copy its camera. You can just copy the camera over and delete the other
Okay.
camera, and make sure it works. If you can move around in
Yeah,
sample scene,
I'm
you
a
should be able to
tester.
move around in this thing. Yeah.
Oh wow. Yeah, I can move around.
Yeah, so just copy that camera and add the player script in the test scene. So just copy it over, and if you
Cool. Thank you.
should be good. It doesn't really matter. Like I literally copied it over from there, so
Yeah.
it's not super important. Yeah, and then in the meantime, load up the terrain script. If it's going to take a while for me to do this, but yeah, because my VS Code is slow. You all might have writer or whatever / booker. But anybody else have any other issues regarding the their camera or their, like, you should see the square there, right? Like below you of terrain.
Yeah, so copying the camera from the sample from the sample scene worked out. It's a pink cube, but it works.
Yeah, okay. Yeah, it'll be a
So,
pink cube.
thank you.
Can you add the player script to your camera as well? Make sure that that's there.
I did, yeah.
Okay, cool. And then yeah, go ahead and open up the terrain scripts. Oh, no. Why is Visual Studio asking for my feedback? No, leave me alone. Okay. 1 second. One second. All right. Okay. Yeah, I hate Visual Studio sometimes. Anyway. Okay. All right. I need to move around my screen. Sorry. 1 second. Okay. All right. Better. Okay. So, does everybody have their terrain script open? Yep. Okay. Okay. Cool. Remus, are you still following along?
Yeah, I'm good.
Okay. Cool. All right. So I'm just gonna. There's a lot already here, and there's some stuff that you might not be familiar with. So I'll just give a general note. It's already implemented, so it's not super important for this workshop, but there's a couple of things that are kind of important. So if we go down to the bottom, there's an update function, and I calculate a chunk index. So I guess I should give an overview of how this works. So there's going to be, a principle for infinite generation is we want to segment our space into smaller pieces, right? So if you're familiar with Minecraft, we have chunks in Minecraft. We're going to do the same thing here, right? It's a segment of space. So what we need to do is we need to segment our own space. So what I'm doing here is I'm getting an index value, an int. I'm segmenting my space into ints of chunks. So I'm giving them x and z coordinate because y is up and down. So we just do chunks on the xz plane. And you can see how I calculate this. It's a little bit of math, but it's not super crazy. The big thing to note is it's the player position divided by the chunk size, basically, and then turn it to an int. And there's a little bit of offsets I have to do because I want the terrain, I want the index to be based off of, I have to account for like negative values and stuff. So like whenever you overlap, there's a bunch of weird stuff that you have to account for, but basically because of how negative space works and how the origin of the chunk in my case is actually the bottom left corner or whatever, I have to do a little bit of extra math. If you put the center of the chunk in the center, then you would have a general piece of math to do that would be a little bit simpler than this. But basically, it's the position minus the chunk size. So what my current position is minus the chunk size, or divided by the chunk size, cast into an int is my current chunk index, right? And then I have a dictionary. So I'm caching my chunks. I have a chunk object, right, that I've created. It's not a mono behavior. It's just a chunk object to keep track of my chunks. And then I have a dictionary of chunks, or of vector 2 ints, which are going to be my indices for my chunk, 2 chunks. So is that clear? So we have a dictionary of chunk indexes to chunks, and then we're just adding them into, if they don't exist, we'll go ahead and add a new chunk. And in the construction of a chunk, we'll do our generation. So that's like generally what's happening here. So yeah. So we have our chunk object, right? This terrain object, this mono behavior, is a singleton, so we can access our terrain stuff, or like our fields, with the instance. So we can do terrain.instance or just instance while we're in the terrain file to get the actual terrain object from our chunk. So that'll be pretty important going forward. And yeah, so any questions, please read through this real quick, just do a little quick gaze over. There is some weird syntax that you might not be familiar with, this like arrow or whatever. I would say don't worry about it too much. And if you're not familiar with serialized field, just think of that as like a public variable in this case. It's not public, but it's semi-public, I guess. It's available in the inspector. But if you have any questions, please, anybody have any questions with this like default terrain code? It's already a lot, I know, so I definitely want to make sure that everything is clear here. So Alexander, the arrow is actually like resolving a function. So this is a property feature in C#. Was Alexander? Yeah, okay, Alexander. So basically, I can pretend that it's a variable. So whenever I access that instance, I access it like a variable, but what it's actually doing is it's resolving this function basically. Like this is basically like it's doing this action.
I think
so it's doing this, but again, don't worry about it too much.
I think a simple way to think about the singleton is just like it makes the script value fields, like the variables, public, kind of.
I wouldn't go as far as saying that. It's singleton, basically singleton, the singleton paradigm, which is what I'm using here, is saying that I'm only going to have one of these objects. So I'm going to allow people to access that one object through a static field to the class. So if you remember, static means that it's across all objects, all instances, right?
So in any script, you're able to access
the one object, the instance itself, right? The one instance. So that's why I use the instance. So quickly, I'm gonna. The important stuff is this chunk object, right? So basically, whenever we create a chunk, we pass in the x and z value, the coordinate, and then we call generate basically. So generate will create. The chunk stores the blocks, the physical game object blocks inside of it. It also stores the mesh renderers, and that's because I want to set the material. So this is just caching the renderer, so I don't have to do the git component, because git component's slow. So it's just a caching step. So I just go through, create a bunch of blocks. I just create a bunch of cubes, and then I call base terrain. And then base terrain is gonna. Right now, it just puts them in. It puts the block in the git position value, and then it sets the material to git biome. So really, what we need to implement is git position, where it'll give the real. We want it to give the position of the position of the block, right? So the real world position of the block, and then git biome will return the material of that block. So I guess the first thing to do, and then I have this get world position, which right now, because the x and y and the x and z values are localized for inside the chunk, so there's 0 to chunk size, which is 16. They're always going to be 0 to 16, regardless of what chunk it is. So this get world position, it's not being called. We should probably call it. Just converts that into real world coordinates. So we do x plus chunk x times chunk size. So does that make sense? Anybody have any questions about that? Because this is really the important stuff here. So if you, I guess I'll clarify this real quick. So right now, notice that there's only one box below us, right? So there's only this plane, right? Even if I go over here, I should be generating chunks over here, but I'm not. And that's because we're not using that get world position. We're setting it to the chunk localized position. So we're actually generating a bunch of cubes in here. We're generating them in the same positions. So we really need to offset these first and foremost to their real world position by multiplying it by the chunk index, right? Because that'll be a scale factor. So if this is chunk 1, chunk 2 is over here, but that real world position, this corner, so if this is 0, this corner here is going to be 16 if my chunk size is 16. Is that clear? So that's the first that's like the first thing we're going to do. So we just need to turn this into a real position. So we'll do vector 2 real pause, or you can call it world pause, whatever you want to call it. And we'll just pass in our x and z values. And again, it's literally that scaling I just said. So we get the chunk size, and then we multiply it by the chunk index, and then we add it by the offset inside the chunk. So now we can do real pause dot x and real pause dot z, or y actually in this case, because it's a vector 2. Okay. So I'll leave that up for a sec. It's pretty simple. Does everybody follow along with that? I'm going to go ahead and show the difference here. And I'll reopen the code in a sec, but I just want to show now that we're actually generating terrain now, even if it's flat terrain. Oops. Okay, get out of here. So now if I walk over here, you see we generated a new chunk and it's actually generating terrain. So please let me know if it's not doing this for you. But you should be here. So now we're generating actual chunks. And they're being put in the right spot. So is everybody there? I'll put this back up. Please let me know if y'all got that. I want to make sure everybody's on the same page here. Can I get a thumbs up if you're there, and if not, like a thumbs down or something. Here we go. Remus, you good? Nada, you good? Oh, well, are you there? Or not? You can just type in chat or say what's up. Did you get the real world position and then set it in the chunk object? Okay. This gives me some time to prepare. Okay.
Gives me vertigo.
Huh?
The camera controller gives me vertigo because you can.
I know it's a little weird because it doesn't limit your yeah. Anyway, so we'll do. So now we need to get our noise value. Like we want to generate some noise. So we'll just go ahead and there's a mathf.perlin noise. Let's go. Okay, so it's pretty simple. We're just gonna get the perlin noise value. Should be pretty simple, right? So we'll do our real pause dot x, real pause dot y, right? And so this gives us a single. We're trying to generate our y value based off of our z or x and z value. So this noise will influence our y value, right? So it's everybody there. So well, I guess I'll keep going for now. I'm not gonna stop at every line. Sorry. So okay, and then yeah, so our y value should be float y will be our instance because we're storing these values in the mono behavior that's instance, right? Dot max height, right? So noise will be from 0 to 1. So we want to get that on a real. Actually, this should probably be an int because we want it to be aligned with the grid. So. So, and then we can go ahead and just pass our y value in right here. So I want everybody to be there. I'll paste this in chat so y'all can have this while I tab out. So let's see what happens now. So we should be applying, we should be getting a random noise value, right? So hopefully a random number that's nice and smooth. We're using it as a height map, basically. We're saying this Perlin noise is going to influence our height based off the random value it is. And then we're going to multiply by max height and then cast it to an int. So it's aligned with our axis, right? Or our grid. But you'll notice that the terrain's moved up, but it's still flat. So this is just demoing that problem that I was emphasizing earlier, that we have a problem here that if we always access at the corners of the Perlin noise grid, it's always going to be flat. And in this case, their grid is based off of like just int indexing, right? So it's going to be like basically 0, 1, 2, 3, 4, 5, 6, like whatever those corners are going to be, they're going to be the same value, right? So we're like asking for Perlin noise values at the corners basically, and that's all we're doing, right? So if we were to like be more granular and look at the inside of a cube, maybe we would get some really cool, interesting terrain. But because we're only asking at the corners, our terrain is currently flat. So that's not cool, and we don't like that, and that makes us sad. I hope that makes sense to people. So we need to get more granular than that. So a simple thing we can do is we can just divide these values. So actually, here's what I'm going to do. I'm going to do vector 2 noise. Okay. We're going to get a new vector 2, and then we're going to divide both of the dimensions by the chunk size. Oops, not chunks. So that way it's a little bit more granular, and those corners are going to be at the corners of the chunk. Oops, noise something. And then I want to be careful about not using real pause here, because I'm eventually going to do some other stuff that I like. Again, we're doing a divide here, and we want to make sure that our real pause is still stored, because we need the x and y values from our real pause whenever we create the final position. So that's why I'm creating a separate variable here for sampling the noise, because we're going to do some modifications to the input of the noise function that'll change how our output is viewed. So is everybody? Oh, somebody said sad. I didn't. Oh, why are you sad? What's wrong? Oh, okay. All right. Oh, yes, it's true. They were right. The world's flat. So sad. Okay. No, the world's not flat. Good news. Now the world is real ugly. It's real uggo. But hey, we got terrain now, kind of. It's really pointy. So I'm not going to interpolate. I'm not going to show in this demo. We're not going to do like edges. You could easily generate like the edges of this terrain, but if you like looked top down, all the points are there, right? But like because it's really hilly, we have a lot of gaps. But this is terrain, but it's not really ideal terrain. Obviously, there's a lot of problems with it that we'll address here shortly. But yeah, so we have basic terrain here. This is pretty much what we're going to be doing. We're just going to be modifying. We're going to discuss how we change this, but this is pretty much it, right? Perlin noise. Pretty crazy. So yeah. And pretty much all the corners are going to be at that same level as they were when they were flat, pretty much. So that's something to keep in mind. But yeah, this is it. It's crazy. So I'm going to go ahead and tab back over so y'all can look at the code if y'all missed that. And let me know, give me a thumbs up whenever you've reached this point and you have terrain that's all wacky like this. Thumbs up from Digo and Alex and Remus. Anybody else following along? I'm basically keeping track of Diego, Remus, Nada, and Alex. And so if anybody else is following along, please let me know. Okay. Wait, Kelly, did you just get in here late? I don't remember seeing your name earlier. I don't know. Sorry if I missed you. All right, Nada, what's the current issue here? Okay, cool, Kelly. So did you? Can you explain to me what exactly you did here? Did you sample the? So you copied the real world position. You had the real world position. It was flat, but it was higher than before, right?
Yeah, I got there.
Okay, and so then you copied that into another variable, right?
Yes.
Okay, and then you divided that variable by the instance.chunk size?
Yes.
Okay. Did you pass in that new variable's x and y value into Perlin noise, or are you still using real pause?
No, I got noise sample.x and .y.
Okay. And it's still flat?
Yeah. Vector 3. Yeah.
Do you want to post?
I'll try one more time.
Yeah. Can you, also, if you need to look at your code, just paste it in the chat. And I'll take a look.
Oh, I'm using two different computers.
Oh, okay. Makes it a little bit difficult. If you want to turn your camera on and point it at your screen, that's fine too.
Oh, that's sure. If that works.
Well, hopefully it will. Oh, yeah, it's a little difficult to read.
Oh, never mind then. That's
it's
okay.
very blurry.
I can zoom in, right?
Oh, here we go. It's starting to let unblur in. So I only see the top of your screen though, so make sure it's at the top. The stuff.
Oh shoot, I can't see my camera. So.
It's fine. Okay, so you got the real position, then you divide it by chunk size. Scroll down one more. Okay, scroll down one more. All right. So show me what happens. Seems like you have it right.
That's personal. empty.
Look down. Can you like move your camera back a little bit, or down a little bit?
I don't think so. Like I'm not getting a lot.
Well, I meant your camera pointed at the screen because I can't.
Oh,
I don't see the terrain at all.
It's not there.
It's just like there's no terrain whatsoever.
Yeah.
Do you see in the inspector the cubes at all?
That's a smart idea.
Well,
yeah, they're there.
Double click them.
Oh. Huh.
And double click your player as well.
I'm using one hand, so I can't. Wait, what I do?
So it seems like the terrain's generating, but it's either in the wrong position or your camera is in the wrong position. Make sure that your player is zeroed out.
I guess my camera's in the wrong position.
Oh, wait, this shouldn't matter.
Is the player the camera? Is that
yeah, the player's
okay.
the camera.
I'm gonna reset the position. Nah, it could be because I'm using. That wouldn't make sense though. They would be like pink cube. Oh, there they are.
It's above you. Yeah, okay, it might be above you. So yeah, you might have to fly up.
Cool. Thank you.
Well, make sure that it's generating adjacent chunks real quick for me. Move around a little bit. Okay, yeah, your camera might be just spawning really low, so maybe just raise the Y value of your camera to something higher.
Oh gosh, I wish I could game
like
properly.
Okay, so it seems like it's working now. So I'm gonna go ahead and move on.
Thank you.
All right, so we have that. So now let's just make it a little bit smoother. So we can multiply by some sort of value, right? Some scale factor that we have control over. So we'll just multiply it by instance dot noise scale. We'll just have some value called noise scale that scales our noise to something like that we want, something that's like, so we can change how granular it is. So if we want it to be more noisy than it is now, we can change that scale factor to be a bigger number. If we want it to be smoother, we can lower that number, right? So in your inspector on grid, you will have a noise scale value, right? Noise scale, which is 1. So I'm going to go back. We're just multiplying that same noise sample value by noise scale. And it's currently 1, so nothing would change if we have it at 1. As you will see, I need to get this out of the way. Sorry about that. Okay, so let me zoom out. Actually, let me not play this in full screen. Let's turn full screen off. Wait, somebody said something in chat. Oh, okay, cool. All right, cool. Yeah. So noise scale is a 1, so nothing's changed. So the terrain won't be smooth if I change this in real time, but we're going to go ahead and do it anyway, just to judge the terrain. So let's just divide this by 10. Oops, that's block scale, noise scale. Let's just do 1 divided by 10, so 0.1, right? And now if we move over, our terrain's like suddenly much smoother. Maybe too smooth, right? So you're welcome to play around with this value, and I encourage you to do that. I think 0.4 is generally good, or 0.3 with what I played with. It's like pretty solid. Maybe that's a little too aggressive. 0.3 maybe. It's got too high angles. But yeah, just play around with this. It's like something I encourage you to do. And something to even keep in mind if you want to do something more advanced than this. Honestly, if you want something more advanced, just do 3D noise. But if you want something a little bit more advanced than this, or something you can even do with 3D noise, is you can layer noise and you have different uses of noise, right? So this value that I'm using, you could put a different noise function to determine the scale value. So that way you have like some higher peaks that are somewhere else, and then like a very smooth area, and like a smoother biome, I guess, if you want to consider that a biome. And you could have even materials associated with that, or color associated with that. You know, with noise, it's a float value between 0 and 1, so it doesn't really matter. We can modify it like the scale value by another noise function. We can modify the color by a noise function, and we're going to do that for biomes. Is we're going to change the material on another Perlin noise function that's just scaled differently, and we'll just pass that through step function. Basically, we're just going to cast it to an int between the length of the number of biomes we have, and that'll change it. Oh, also, Nada, if you want to create materials, there's this biome thing. If you don't want it to be all purple, go ahead and just create some dummy materials and plug these in.
Nice, thanks.
So yeah, I would recommend you do that. Yeah. So I'm actually going to go with 0.2. I think 0.3 is even a little aggressive here. 0.2 seems nice. Yeah, that seems pretty good. Or 0.1. 0.1 actually was pretty good here. So again, so now we've pretty much done it. We have Minecraft. Good job, guys. Everybody here? Everybody have terrain generation at a good level that they're happy with? So that's Rodrigo. I saw Nada. I saw Alex. You're good. Remus, are you there too? Sorry, I didn't see if you thumbs up. Okay, cool. Okay. So yeah, make sure your biomes list has got some materials in it. You can add as many materials as you want. We're gonna do biomes now, just to show off this kind of thing. And we're gonna do literally the same stuff that we just did. We're just gonna use a different scale factor. Okay. So we can actually literally just copy and paste this code up to Y, or yeah, up to Y. We're just gonna use the same thing. And maybe we should probably put this in its own function or something, but I'm not gonna care to do that right now. You know, just go ahead and copy and paste real world position, noise sample, and noise scale. But yeah, we'll go ahead and use a different scale factor that's much lower. I did skip over something. Again, it doesn't really matter where you sample your noise from. So in my final solution, if you look at my, like, there's a final folder with my final terrain, I use an offset as well. You can offset where you sample your noise from. Instead of just sampling from this exact thing, you can add an offset. So that's something else you can do if you want to fine tune how your noise looks. That's something you can do, but we're not going to bother doing that right now. So we're just going to use another scale factor that's like smaller. I don't know. What's a good scale for 125? That seems good enough for me. Not much smaller. It doesn't actually need to be much smaller, but we're gonna pass it through a step function. But a somewhat smaller scale modifier. Or actually, we'll just, again, it doesn't really matter how we do this. So we're just going to apply that on top of our current scale factor. So I want to make this higher because we want our biome scale factor to be always a little bit, always smaller than our noise scale factor. So I think I'm just going to apply it on top of the noise scale factor. So does everybody ever have this pretty much copied and pasted their old code, added biome scale, and then now we're sampling some noise? Cool. I'm not going to harp on this too long because I'm going to keep writing code here so y'all can keep following along. So yeah, now we just need to pass this through a step function basically. So we just do our index. Right, is just in cast of that noise value, because noise is always going between 0 and 1, right? We're going to just multiply that by the length of our instance.biome array. And then we can just go ahead and pass that into biomes. Is that clear? I'm going to go ahead and try it out real quick. And I'll go back to the code after I try it out just to show you it. And then we'll... And biomes, again, like if you were to do a real scenario here, like a real Minecraft, you should probably abstract all this stuff behind like other objects. But because it's a very simple example, we're just going to use straight up an array of materials. You might want an actual array of biomes with some other metadata that you might want to store. So you see here, we were on this metal biome, and now we've met the boundary of that, and now it's sand, right? Or I mean, it's yellow versus this other material in this case. So it's not super advanced, but yeah, biomes, they work. Yeah. And so I'll go back to the code so I can see that. And I'm gonna wait for some OKs. Oh, looks like Nana dipped. Diego and Remus, are y'all caught up? And Alex? Yep. Remus, you there? Remus, are you there? Hello? Oh, you caught up? If you're not, let me know. Oh, okay. Again, most of this is just copied from up here. It's the same idea. We're just using Perlin noise in a different way here. A slightly different way. Very slight. All right, cool. Looks like not a left, so I'm gonna go ahead and move on. So the next thing we can do is we can spawn some trees. And in order to that, we're going to use that other algorithm I mentioned, Poisson disk sampling. Now, I'm not going to go over implementing Poisson disk sampling. I've already done it for you. So we're just going to add it in. I'll show you. I'll do a quick explanation of it, of the, not the algorithm itself. Maybe I will, but like mostly the object here. So basically what I've done here is I've created an abstract class called a point generator. And this is just to I guess I could actually make this an interface. It should probably be an interface. I don't know why I made an abstract class. So really it should be an interface. Yeah, interface, right. Yeah. Right. This is what it probably should be, but same idea anyway. So yeah. I made an interface for point generator. You can keep it as an abstract class. It's only got generate, so it should be an interface. But anyway, point generator has an IEnumerable vector to generate. And what this means is an IEnumerable, what you can do is create a function that yields values. This is like a C# thing over time. So you can say like, you give yield statements where it'll return that value, but then you can call, basically it'll call it again. So you can put a for each loop over it or something, and it'll run a certain code until it hits a yield statement, and then it'll continue, and then it'll return whenever it hits another yield until it's out of yields, or the function finishes. So, and then I have an implementation of this interface called Poisson disk sampler that does the Poisson disk sampling. It's got a constructor which requires a radius. So we want this radius is the amount of space, the minimum amount of space that we want to make sure that is in between each point. So there should be no 2 points in a chunk that are closer together than this radius value. If that makes sense. What? Where? Okay. Oh, maybe not then. Maybe just keep it a abstract class. It's chilling now. Oh, it's because it was overridden. That's why. I can make it an interface. I just need to undo the override. There we go. But yeah. So yeah. So yeah, generate. In this case, we'll do the Poisson disk sampling algorithm that I was talking about. It's a little bit dense and complicated. I can explain to you if you really want to. But the basic idea is like we're gonna take 2 points, and or we're just gonna randomly choose an angle from a point. Like we just pick a random point. We start with a random point. We pick a random angle, and then we pick a random distance between that radius value and 2 times that radius value, and we get a new point from that angle, plus we get the like vector from that angle, and then we multiply it by the magnitude that we just generated. And then from that new point, we just make sure that it meets that condition that every other point's spaced out. But then there's an optimization involving segmenting space. Again, segmenting space is very important in procedural generation. That allows us to really optimize that step without us having to really check against every other point, right? We can make an abstraction over there. And so that's how it's done. So you can see these yield return statements. Again, this was a show for the yield stuff. So it'll return this sample, and then it'll return this point until it's done, these points. So in order to do this here, we'll probably want to do this in base terrain. We'll want a point generator. Point generator equals new Poisson disk sampler, and then we'll give it a radius. So there's an instance dot tree radius value. So let's get our generator object instantiated whenever we generate our chunk. Oh, not at your back. Sorry. Nada, did you get your terrain working for the for like just the smoothness, the multiple here? This. Oh, you had that working, right?
Yeah, I think so. I don't know. I just got like a bunch of metal material terrain.
Okay,
And
did you get the
then-
biomes working? Were you there for that?
Are the biomes supposed to change?
Yes. Oh, yeah, I guess you weren't there for that though. I think you dropped for a second, right?
Yeah.
Okay, so
It's okay.
yeah, I can just I'll send you this and then I can explain it to you after we're done here. But like, just copy and paste this. Oh, I guess you can't copy and paste. So.
No, I'll copy it. If you like put it in chat.
Yeah, I'll put it in chat.
Cool, thank you.
The EGaDS Discord, I could copy the code in.
Yeah, that might be good.
You want to?
But,
This,
yeah.
I already got it. But
So
thank you, though.
it basically just a quick synopsis of it. Like for get biome, we just did the same thing we did for terrain generation, but we like scaled it lower so that the scaling was like even flatter basically than before. And then we just passed it through a step function, meaning that we just casted it to an end. Well, we first multiplied it by the number of items in the list and then casted it to an end to get an index for the biome, which
Cool.
is just
I think I was here for this.
Yeah.
Yeah, because I already have it. I just ended up getting one type of biome. I don't know
if you
that's
want, you
just-
can lower this biome scale factor, and it should be more frequent. It'll be very like long, and also it depends on how many biomes you have in your list.
That
The
makes
more
sense.
biomes you have in the list, the more frequently they'll change.
Cool.
Okay, so we're here. So we have a point generator, which is this class that I showed, this interface, and we've instantiated a Poisson disk sampler, which it's just an object that will give us points, vector 2s. So we can do for each, okay, vector 2 point in pg.generate, right? So we'll call that generate function here. And this will just iterate over that list basically and give us the points. Right, so now we have a bunch of points where we want to spawn our trees. Yep. So we can get our points. So we want to cast them to ints. So because the point generator returns like vector 2s, right? That are not axis aligned to our grid, and we want everything to be along our grid because it's Minecraft, right? Everything's very cubular. If you didn't want that, you could not cast it to it, but we're just going to do that here. Get our z value here. Our y value. We want to get our position for the terrain position because we want to spawn this tree. This is a vector 2 point, so we can like look at the top down. Actually, we can just do this. Actually, we can do. Wait, no, we want this. Yeah, so we'll get the position of x and y. Right? And then we want it to be one block above those blocks, right? So we want to add a block to it, so it's not in the terrain. We want the tree to be above the terrain. Oops, I forgot to give this a name. So we want to get our terrain position for this specific XZ coordinate that the base terrain position, and then we want to add one so we can spawn our tree above it. There's probably a better way to do this. Like we have the grid already of terrain, so it's probably best to just access it there instead of calling this function again, which might be a little slow, but that's actually not the slowest part of this, so I wouldn't worry about it right now. The slowest part of this whole thing is the fact that we're using cubes instead of like meshing this whole thing as one big mesh. Each chunk should probably be its own mesh, but what you gonna do? That would be a whole nother thing. And then we just instantiate our tree prefab. Instance dot tree prefab at this position at determine dot. So that's the basic implementation of trees. I'll go into the Poisson sampler if y'all want. But this is pretty much the whole workshop. So after this, I have nothing more to really teach y'all. I can go over those other things like the Poisson sampling or the layered textures. But again, that's like really just extra. It's already implemented here for y'all, so y'all don't have to implement it. But yeah, so we can see now we will have trees. Oh, sorry. Yeah, okay. So wow, look trees, crazy. Oh, your trees are gonna be pretty purple. No, yeah, because the leaves are yeah materials. Yeah, but and we can change the spacing of the trees. There's a spacing value for the radius. I remember we have that value in grid. There's this tree radius. So if we want them more spaced out, I did this on a per chunk basis. We're spawning this per chunk. The smarter thing to do would to do this would to be doing this outside of a per chunk basis. So I've done it before where you do it on a 5x5 chunk grid basically, and the benefit of doing that is that you don't get trees next to each other on chunk boundaries. Because the problem with this is like on a chunk boundary, the trees are going to overlap. But that's fun for this demo. So if you want to do something a little bit more intelligent, you could have a 5x5 grid of chunks where you would generate the tree zones, and then you would just do that over and over again for each chunk. Or not 5x5, a 3x3. But yeah, so now we have more spaced out trees. But yeah, so there's Minecraft in Unity kind of a little bit. Very jankfully, but kind of Minecraft, right? Something. All right, well, that's pretty much it. I'm gonna pull up the code again so y'all can copy this if y'all didn't get it. But any questions, please ask questions. That's what I'm here for. And also, yeah, if y'all want, and if y'all want to stick around and talk about the Poisson sampler or the layering, like using this in like a shader way for like the layering of stuff in the shader or whatever, layering of different noise textures and shaders, yeah, please let me know.
Also, all the code will be posted in the EGaDS server, and this has been streamed and recorded, so that'll be uploaded to our YouTube channel in case you need to like rewatch anything.
Yay! So everybody get treason?
Bro, the cherry blossoms are in.
Cherry blossoms.
Everything's pink.
I stopped following along after I cut out, to be honest, but it's okay.
Yeah, that's fine.
Yeah.
That's I mean, it's just trees.
Nothing special or anything.
Nothing crazy. Okay. Does anybody want to just want me to explain either the Poisson sampling or the material here for grass, the grass material?
Before you do that, just to clarify to see if I understood like how we use Perl and noise.
Yeah.
So the reason that all the blocks were relatively smooth is because Perl and noise is like a smooth out version of just like a regular noise map.
Yeah.
Okay. And if it was just noise where it's like white or black, it'd be like super jumpy.
Yeah, I think we might be able to just test it. I don't know if Unity has a built-in noise function, but noise is literally just random, right?
Okay.
So we could replace our Perl and noise here for get position with math or like we could just do float noise equals random, where we just do some sort of hash of the x and y values. So like noise. I'm just gonna multiply them. It's not a really good hash, but noise sample that x.
Doing hashes now. Oh yeah. Also, I'm gonna stop streaming.
I'm just gonna multiply. It's random dot